Hello students, today we are going to start a new chapter, that is chapter 10, circles. So let us know what is a circle. A circle is a collection of points on a plane which are at a constant distance, that is radius, from a fixed point, that is the center. So let us understand this definition with a diagram. Okay, so it is said that it is a collection of points, okay, on a plane. So suppose this is a plane and then you have a collection of points. So you have a collection of points, okay, and this collection of points which are at a constant distance means the same distance, okay, from a fixed point. So let us take a fixed point, say this is the fixed point, okay, and which are at a constant distance, that means these points from the fixed point, suppose this distance, you join any point, or whether you join here, anywhere, all the distances are constant, okay, that means all the distances will be same. So now let us just join all the points, okay, and this is the fixed point, that is the center. And what do you call this distance? This is called radius, okay. So a circle is a collection of points. So you have so many points, okay, I've just joined all the points which are at a constant distance and from the fixed point. So from the fixed point, all the distance, whether you join this point or this, wherever you join, all the distances will be same. So that is the definition of circle. Okay, so now let us understand the relation between a circle and a line. So this is a circle, suppose this is a line, okay, so line segment P Q. So let us understand the relation between a circle and a line. So there can be different possibilities, so let us check the first one. Okay, you have a circle and then you have a line. So this is line segment PQ. So in this figure you can see that this line and the circle, they don't have any common point, right? This line is not intersecting the circle. So what do you call this type of relation? So in this case, this PQ line segment, this PQ is called non-intersecting line, okay. This PQ is called non-intersecting line with respect to the circle, because as you can see in the figure, this line is not touching the circle, right? So it is called non-intersecting line. Then the next case, first you have a circle and this line, it touches the circle at one point, okay. This line segment PQ, it touches the circle at this point, say it is touching the circle at point A. So what do you call this type of line? So this line is called tangent, okay. So you can write a tangent to a circle is a line that touches the circle at only one point, okay. So as you can see in the figure, this line is touching the circle at only one point, this point A, right? So this line is called tangent, okay. Then the third one, you have a circle and then a line is intersecting, okay, and this line is intersecting the circle at two distinct points, A, B. So this line segment is PQ, okay. This line segment PQ is touching the circle at two distinct points. So what do you call this type of line? So this line here, the line, okay, PQ is touching the circle at two distinct points. Okay, so what do you call this type of line? So these are called secant. Okay, if a line touches the circle at 2 points, okay, 2 distinct points, then that line is called secant. So you can write this line is called secant. S-E-C-A-N-T, secant. Okay, so these are some of the relation between a circle and a line, but here in this chapter we'll study more about this tangent. Okay, and what is a tangent? A tangent to a circle is a line that touches the circle at only 1 point. Okay, so now I'll discuss about 2 theorems. I'll just give the statement. Okay, those will be important for the exercise 10.2. okay, we'll use those theorem to prove the questions. So the first theorem is the theorem 1. It is there in your textbook also, you can refer that. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so what does this mean? So let us draw the figure. The tangent at any point of a circle. So let us draw a tangent. So you have a circle, okay, and then let us draw a tangent. So this is PQ, and this tangent is touching the circle at this point, say A. Now what does it state? The tangent at any point of a circle is perpendicular to the radius through the point of contact. So perpendicular to radius. So you have a circle, this is the center of the circle, so let us draw the radius. So this is the radius, okay, R, and this is the center O. So it says that the tangent at any point of a circle is perpendicular. That means this tangent, okay, at this point A is perpendicular to the radius. Perpendicular means 90 degree, okay. Either you move this side, this angle, or this angle, it will be 90 degree. So this theorem states that the tangent at any point of a circle is perpendicular to the radius. Okay, this is the radius through the point of contact, and this is the point of contact. Okay, the common point between the tangent and the circle. So this common point is called point of contact. Okay, so this is the first theorem. Then you have one more theorem, theorem 2. The tangents drawn from an external point to a circle are equal. So let us understand this with the help of a figure. So what does it say? The tangents drawn from an external point to a circle are equal. So let us draw a circle, and then you have to draw tangents. Tangents, that means let us draw 2 tangents from an external point. That means outside the circle. Okay, suppose here you have an external point P. Now let us draw 2 tangents from this point. So let us draw one tangent here, another one here. Okay, so this is the center of the circle, and so this is the radius. Okay, we'll join the radius. This also let us join. So this point is A and B. So this theorem states that the tangents drawn from an external point. So these are the 2 tangents, right? PA and PB, and it is drawn from this external point P. So that means these 2 tangents PA and PB, they will be equal. Okay, so you can write PA is equal to PB. Okay, so this is theorem 2. So these 2 theorems we'll use in exercise 10.2 to solve the problems. Okay, so now let us do exercise 10.1, question number 1. How many tangents can a circle have? So as I have already explained the last that What is a tangent? Let us draw it one more time. A tangent is a line, okay, drawn to a circle, okay, that touches the circle at only one point. Okay, so suppose you have a circle, say this is a point, you are drawing a tangent here, so it should touch the circle at only one point. Okay, so in a circle you have so many points. Suppose you have a point here, so you can draw one tangent here. Say you have a point here, so we'll draw a tangent here. Say you have a point here, so we can draw a tangent here. So like this we can draw infinite number of tangents. Okay, so we can say that in a circle we have infinite number of tangents. Okay, this is a small circle, you can consider a bigger one also. So there will be infinite number of tangents in a circle. So in the answer we can write a circle can have infinite number of tangents. Okay, then next is fill in the blanks. Question number 2, fill in the blanks. Question number 1, you have a tangent to a circle. You refer your textbook, okay, it's there. A tangent to a circle intersects in its intersects it in dash points. So as you can see in this figure, tangent is a line, okay, drawn to a circle at only one point, right? A tangent intersects at only one point, so your answer will be a tangent to a circle intersect it in one point. Okay, then the second one, a line intersecting a circle in 2 points is called a, what do you call it? I have explained earlier that, as you can see here, this one, you have a circle and this line is intersecting at 2 points, right? So this type of line is called secant. Okay, so the answer is secant. Then the third one, a circle can have dash parallel tangents at the most. Okay, now let us understand this. How many tangents a circle can have dash parallel? How many parallel tangents can a circle have? So you have a circle, okay, what are parallel lines? Suppose these two are parallel lines, right? Then how can you say that these two are parallel? Suppose it is intersected by a transversal. This one I think I have studied in class 9 also. So if two parallel lines are if two lines are intersected by a transversal, then the alternate angles are equal. Okay, so this angle, so angle 1 will be equal to angle 2, and this angle 3 will be equal to angle 4. So if the alternate angles are equal, then you can say that these two lines are parallel. So in a circle also, suppose you draw a tangent, okay, and here another tangent, and then this is the diameter of the circle. So if you can prove that this angle, see, this is tangent and tangent is perpendicular to radius, right? So this is 90 degree, this will also be 90 degree. Similarly here also, this is tangent is perpendicular to radius, that means this is 90 degree and this is also 90 degree. So all the angles are 90 degree. So you can say that this angle is equal to this, right? Because both are 90, alternate angles are equal here also. So if the alternate angles are equal, then the two lines are parallel. So in a circle also, at the most you will have two parallel tangents. Okay, you cannot have more than two parallel tangents. So your answer will be 2. Then the last one, number 4, the common point of a tangent to a circle and the circle is called dash. So what do you call that point? The common point of a tangent to a circle and the circle. So suppose you have a circle and you have drawn a tangent, okay? So this point, okay, this point is common to both, right? Both the tangent as well as the circle. So this point is called point of contact, okay? The common point between the tangent and the circle is called point of contact.